about the families.
Your parents didn't confirm anything about the YBTC with me yet. So maybe they are planning to appear next year?
I don't know. I thought my dad texted you.
No,
Oh,
didn't discuss anything with me. In fact, I requested also to have some kind of meeting, but that's fine. If you are planning to appear next year, that's okay. That would be better because by that time you'll be master of everything. So do let me know whatever way they are planning to decide. You discuss with
okay.
your father and let me know. Okay.
Okay, sure.
So we did alkali metals, potassium, magnesium, calcium. Then we started working with the iron, right?
Yeah, we looked at iron.
Mhm.
Um,
Then
and I
zinc.
remember,
See, this is zinc. Zn. It is also you see bluish, shiny metal. So they are just telling you the uses. Like zinc is used in cell batteries. You have seen batteries?
yeah.
So these batteries, they have metals in them. Metals with some other material. So dry cell batteries means nothing is liquid, everything is dry. It is also present in alloys. I think yesterday I told you the meaning of alloys.
I
Remember
think,
the word brass?
oh
Check.
yeah, brass is copper and zinc.
Yeah, very good. So it is
Bronze
a
is
part of
copper.
many. Yeah, bronze is copper and tin. Correct. So the zinc is used in making alloys with copper, nickel. Nickel, symbol?
I think it was, oh, and I,
Yeah. Aluminum, metal, another metal, Al, lead. You know why they try to make these alloys? What is the reason? I think I gave you the example of steel. Steel is an alloy of iron,
what do
but
you
iron can
mean?
undergo rusting. Iron
Yeah.
can undergo rusting, right?
Mm-hmm.
Do you think steel can undergo rusting?
Um, yes.
No. You are using steel utensils in your home, right?
Oh, yeah. Yeah, they don't rust.
They don't rust. So
Steels,
alloys are generally with improved properties, right? On this. Alloys are with improved properties.
I have a question.
Mm-hmm.
I think last class I asked um about the quiz. I forgot to mention it in the end.
Okay, but you said that you have understood this.
Like the quiz, like the dragging and the
Drop. Mm.
dropping. I didn't see.
Yeah, you
Um,
you can share your screen. Show me which quiz you are talking about.
okay. Let me- Um, okay. Um, okay. So is this one? I don't see. It says like drag and drop, but I don't see anything.
Can you
Like,
scroll down? Scroll down. These are
oh,
the
I
right?
didn't realize that.
Just drag and drop. Just show me once. Anything, anyway. Yeah, like this, right? Okay. Mm-hmm.
Okay.
Now you can stop sharing. Yeah, leave. Okay. Back to our learning.
Yeah.
So what are alloys?
Improved properties.
Of the
They're
metals?
mixed
Yeah.
of the metals.
So if somebody asks you that, why we want to make alloys? So you will say alloys have improved properties.
Properties
Mm,
of metals.
of metals. Yeah. Improve properties. Then you can give the example of the steel. Like iron can undergo rusting, but steel cannot undergo rusting. So improve properties of metals, right?
Hmm. Properties of the metals.
Mhm. Like steel, no rusting. It is a form of
Rusting.
iron only, iron mixed with other metals. Steel is mainly iron. Then there is some chromium, copper, and traces of nickel and other. These are the main three things in steel. But there is no rusting. Because of the carbon and chromium, there is no rusting. No rusting. But iron, pure iron,
Rusting.
rusting. Pure iron can go under rusting, undergo rusting, right?
I also had another question.
Mhm.
In the end of class, you said after we're like gonna we should read all these like elements and stuff,
Mhm.
and then said you were gonna like teach another unit after the one.
Yeah, then
It
I'll start
was
with matter and classification.
yeah.
And then there is one more unit left, atomic structure, matter and classification. Atomic structure, only some part is left. Matter and classification is also very simple, will go very fast. Half of the time we are doing that. And the one unit that is nuclear reactions and laboratory apparatus. So we are going to do all these things. Okay. Okay. So ready for next metal?
Yeah.
So they say you have seen white paint, thick white
I
paint.
have I see it a
You
lot.
know, it is a zinc oxide is the pigment over there. It's white in color. Zinc compounds are generally white. They are not colored. They are white. Though it's a transition metal, but they are white. It's an important
Oh, that's
pigment.
interesting.
Mhm. It is also present in cosmetic and ointments. It's good for skin. So just read about it and leave it. You have the
Okay,
basic
I'll
knowledge
read
of
about
these
it.
metals. Yeah. Silver. Looking
Um,
for silver.
it says it's very malleable and ductile,
Yeah,
so
you
it's
know
you
that
can
you're using.
stretch.
Yeah, you're using it in jewelry, right? So you can use in jewelry only those metals which are very malleable and ductile because jewelry needs thin wires, thin sheets. So you can use only those which are very malleable and ductile, right?
Yeah,
You already know the color of the silver.
yeah, it's like a gray kind of white.
And it's very good in thermal and electrical conductivity. It is very good in thermal and electrical conductivity. You know, it is so good.
Like
Thermal means heat. Thermal means heat.
heat.
And all metals, they conduct electricity. Why? Metals are good conductor of electricity. Do you know the reason?
You talked about it in
Hmm.
the, I don't really remember.
Due to the presence of free moving
Oh, free
electrons.
moving electrons, yeah,
Yes, yes. Metals
it
are
is.
good conductor. Write it
Oh
down.
yeah,
Okay.
Only, yeah, I remember you did say it. Only free moving charged particles can conduct electricity.
Very good. And in metals, we have free moving electrons, right?
Electrons.
In metals, we have this.
Mhm.
So silver is otherwise is stable. You know, you can see pure silver in the market in the form of jewelry, but it does react. Slowly it reacts. Its reaction is very slow. It reacts with sulfur present in the air. You know, silver metal, their utensils, they become tarnished. Tarnish means black. And you rub it with soap and you will see it will become silver again. So silver, write on this reaction. Silver reacts with sulfur to give you Ag2S. Where is this sulfur? It's in the air. Sulfur or sulfur containing compound. This Ag2S is black in color. Black in color.
Mm.
And this particular reaction, this one, is responsible for tarnishing silver. Tarnishing. Tarnishing of silver.
So
See?
does that mean two sulfurs
Yeah, 2
mixed
Ag.
with
Yeah.
two Ag with two
One sulfur.
one sulfur
Mm-hmm.
and
Ag2S.
it's black in color.
Yeah. So, are you clear about the tarnishing?
Yeah, tarnishing.
So, they say silver is good if it is not tarnished. If it is tarnished, then it's not a good silver, right? Then this is one of the alloy of silver. Silver alloy. Sterling silver. It's a very popular alloy which is there in the market. Sterling silver. It is mixed with 92.5% silver and 7.5% copper. It's a mixture of two metals, right? So more is silver and less is copper. This is also called as alloy. So we discussed the alloy of copper, brass, alloy of zinc, brass. Now this is the alloy of your silver. Sterling silver. It is also with copper. And steel is the alloy of. So you have to understand these few words, right? In the sterling silver,
Yeah.
the sterling silver has actually very soft. It's not, sorry, not the sterling, the pure silver. Pure silver is not very hard, but the alloy of the silver is hard. That's why you can use it in the jewelry. If you take pure silver, jewelry will be weak. It will break down easily. But when you take this sterling silver, then it's slightly harder. Same with gold. Gold also is mixed with copper to make it harder. If you take pure gold, it's soft. If you see, you ask your mother, she will say, oh, this is 22 carat. Something like these types of words they use. 18 carat, 22, 18, 24. 18 carat is used in your all these diamond jewelries. Gold is the base, and on that diamond is embedded. So we add other metals to make them harder, to make the alloy. So gold is also mixed with, they mix gold with copper. And depending upon how much percent of gold, how much percent of copper is there, we have different level of golds. 24 carats, 22 carats, 18 carats, like this. Is it okay? Ask your questions. The spelling of the carat is this. C-A-R-A-T. Carat, not O-A-T. So if it is the pure gold, 24 carat is the pure gold. It is the pure. This is soft. Not good for making jewelry. If you make a jewelry out of it, it will break down easily. Right? So to make it harder, let's say 18 carat is very hard. In 18 carat, there is 75% gold and 25% copper. So 18 carat is hard. Right? If you purchase a jewelry of 24 carat, it will be expensive. If you purchase jewelry of 18 carat, it will be cheaper. But the one which is of 18 carat is durable, more harder. 24 carat jewelry,
Softer.
soft, bangles will bend. Like I do have of 24 carat bangles. I have very serious problem with them. So I'm not wearing it because they just bend when I'm working. If you put some pressure, they bend from there because it's 24 carat pure gold. That's why. Is it okay?
Yeah.
Okay, I'm going to clear it. So that's about the silver. Uses of silver, sterling silver. Then we have mercury. Where are we using mercury? In thermometers,
Yeah, thermometer.
not joules. Okay,
Wait,
it's
jewel
liquid.
is oh,
Mercury is the only liquid metal. You're aware of that? Are you aware that what all are liquids and solids in the periodic table?
not really.
No, don't tell me. Let's do it again. So I'm going to share the periodic table with you. Here. So with one easy understanding, you can identify what all are solids, what all are liquids, what all are gases. Okay. Are you aware of the gases, diatomic gases in the periodic table? Diatomic. Di means two. Diatomic gases. So what are the diatomic gases? H2, right?
Two. Yeah.
And just think about the air. What are the gases in air?
O.
Is it O or O2?
O2.
Yeah. What else? N2. What else? Some traces of argon is also there. But what are the diatomic gases which are made up of two atoms? And how many diatomic gases are there?
3.
No, 5. H2, N2, O2, F2, Cl2. Please write down this. So H2, O2, N2, F2, Cl2. These are diatomic gases. Diatomic. And what are monoatomic gases? Monoatomic. Noble gases, they are monoatomic. Monoatomic
Gases.
means one atom. What are those? Argon, this helium, right? So let's start with helium. All the noble gases.
Yeah, all the noble gases.
All the noble gases. You can make the list. Helium, neon,
Neon, argon, krypton, xenon,
radon.
radon, and
Oh, leave this. Let's not talk about this particular period number, right? 7th. Most of them are radioactive, right? Okay. So you are clear about the diatomic gases. You are clear about the monoatomic gases. Now I'm going to show you two liquids. In the periodic table, there are only two liquids. One is mercury. You can see mercury here, this one, transition metal. And other is bromine. So how many liquids are there? Two liquids. What are those two liquids?
mercury and bromine.
Yes, mercury and Br2. These two are. Is it okay?
Yeah.
Okay, so that's the story about your two liquids, mercury and. So in the periodic table, Br is not a single atom, it's Br2. Just like
Okay.
F2 and Cl2, all these are diatomic. All these are diatomic. F2, Cl2, Br2, I2, like this. Is it okay?
Wait, I have a question. I
Yes,
thought you
please.
said diatomic, the only ones were H2O2, N2, F2, and Cl2.
Yes, they are the diatomic gases.
Oh, just, you mean
Gases.
just diatomic was F2, Cl2.
Gases.
Oh, okay.
But if it is Br2 diatomic, then it's a liquid. Is it okay?
Oh,
Then
wait,
you
I
can say.
haven't,
Yes,
can you say diatomic liquids too?
there's only one, right? Yeah, you can say diatomic liquid, but there's only Br2 because in total there are only two liquids. In total, there are only two liquids, mercury and Br2.
Mhm.
Rest all are solids. You have written these rules? Can I test you?
Okay.
So I'm going to
Yeah.
clear this. You write on everything and give me 1 second. Okay, I'm back.
Yeah.
So, is it okay? Ready for test? Okay, fine. I2, solid, liquid or gas?
Solid.
Very good. SE, solid, liquid, or gas?
Solid.
BR2, solid, liquid, or gas?
Liquid.
You said something?
I said liquid.
Perfect. KR, solid, liquid, or gas?
Gas.
H2,
Gas.
very good. S8,
Solid.
HG,
Liquid.
yeah, see? Now you know the state of every element in the periodic table, right? When it is in the elemental form, you know what all are gases, what all are, most of them are solids, most of them, right? All metals are solid. Two of them are liquid. And then we need to know diatomic, monatomic gases. Can you name all 5 diatomic gases? 5
Diatomic
diatomic.
gases.
Name them.
Nitrogen, oxygen, fluorine, chlorine, hydrogen,
Yes, hydrogen, nitrogen, oxygen,
oxygen,
fluorine,
fluorine.
and chlorine. These are the only 5 diatomic gases. Good. So it's a good information which you have to retain. So mercury is liquid, right? So under normal condition, it is liquid.
Right.
And it is also called as hydroxyrum. Hydra means water, liquid.
Water.
Yeah, so hydroxyrum, they say liquid silver. Earlier, people used to call it as liquid silver because it is also white, shiny, but in the liquid form. Okay, and is also called as quicksilver. These are old Greek names, old names. Now we are not using them, and I don't think they will ask it. Its melting point is very low, 75 degree Fahrenheit. 75 degree Fahrenheit is high temperature, low temperature in your country. It's cold.
Yes.
It's cold, right? Because body temperature is 99.8
9.8
degree
degree.
Fahrenheit, right? 99.8. That's the body temperature. So 75 degree Fahrenheit is
Oh,
below body
that'd be
temperature. So that is,
that'd be cold.
yeah. So its melting point is very low.
And
This is the
above,
only liquid at room temperature, right? Because if room temperature, what is the room temperature in your country? Around what temperature you keep that thermostat of your house? Did you check?
um,
Okay, next time
I
tell me
think
that on an average, at what temperature you keep the thermostat. And that is the room temperature.
I
That's
think
the
it's like
norm.
7.
Hmm.
I think I don't think this. I don't. Maybe
Maybe what?
70.
Room
Wait.
temperature of in degree Fahrenheit. In degree Celsius, it is 25. But in degree Fahrenheit, we have to do the conversion. Oh, they are taking 20 degrees Celsius as the room temperature. Then it is 68 degree Fahrenheit.
58. Oh, close to 7.
You must be keeping your room temperature somewhere around 70, right? Okay, so mercury is used in thermometers, in barometers. You know what thermometers are going, what are they used for, thermometers?
We're measuring temperatures.
Do you know what barometers are used for?
I've heard of it. Maybe I think is it used for
Pressures.
pressure? Okay.
Okay, and they are saying it is used in vacuum pumps also, barometers, thermometers.
Hmm.
But mercury is very poisonous. It's very toxic. Let's say you're using it in thermometer. So you know that people they keep purchasing new things. Thermometer will break down or is not working. You just throw it in the soil, in the dustbin. Whatever you're throwing
Yeah.
in the dustbin will go in the soil.
Hmm.
So in this manner, if thousand and thousand people are throwing these small thermometers, then can you imagine how much mercury has gone in the soil? And that
That's
mercury will go
bad.
in the water, drinking water.
Hmm.
So there are many countries in which they report that water is poisoned by mercury. Mercury is very bad for health and it destroys the nervous system and the immune system. You know the nervous system,
Isn't the nervous system like your
the brain. Brain
brain?
has
And then,
so many
yeah.
nerves are there which are spread out all over the body, right? Central
And
nervous
then,
system and
the
immune.
immune system. Immune system is like if you get sick, you like
Fighting with the disease, right?
fighting the disease because
Yeah, that is
you're
immune system. Okay. So if this mercury level is high in the drinking water, then that water is unfit for drinking. Similarly, there's one more
okay.
element, arsenic. Can you check? Arsenic is like a
Arsenic.
poison. Yeah.
Oh yeah, arsenic.
Nitrogen family?
Yeah.
Nitrogen family is right. It also is very poisonous. Arsenic and mercury, if they're in the water, that water is unfit for drinking. Okay.
Actually show up. Have they ever actually up in
Say
water
again.
before? Have they actually shown up in water, drinking water before?
Where? Yeah, it is
Like,
there.
general.
No, there are many
Oh,
countries where the arsenic level is very high. Like I was reading a newspaper, I was reading a news, I think 2 days back, and they reported that there is a village in India where when they tested the water, drinking water, they found a very dangerous amount of arsenic in that. And you know that what happens? The whole village is drinking that water. And you can see everyone in the house is ill. If everyone in the house of certain area is ill, everyone, then it means something is wrong with the drinking water or with the air. Am I right? Because air and
yeah.
drinking water is common for all of them. So when the scientists they found that everyone in the house is not well, then they realized that something is wrong either with
That
the air
something's
or with the
wrong.
water. So they tested the water and they found too much arsenic in the water.
And
So,
that
hmm, so that
could like
prices,
it kill.
mhm, yeah,
Can it like possibly kill you?
say again.
Could it possibly kill you or something?
Yes, arsenic can kill a
It's
person.
really
Yeah, but
toxic.
once you know that your body is poisoned by arsenic, then there are medicines to throw out this arsenic from the body. Same with mercury. So at least we must know that what kind of poison is harming our body. If we know this is the poison, then doctors have medicines for that, right? So that is the
Mhm.
reason we should follow a kind of, I don't know, I must tell you because you are young children, try to be less dependent on materials. Use less materials. Materials means clothing, bags, so many things we are using and throwing. We have some extra clothes. We have extra amount of things. We are just storing them and then without using, throwing them away. So we must have the habit of using less material. Try to have a simple life with minimum materials. This can help in cleaning the environment. Okay. Kyra, where were you?
I had some problems
With
like
you
with internet.
say again?
With internet.
With internet. Oh, okay, okay. Generally young children, they are fighting with the parents and they get angry and they don't come. Okay, like my younger son, whenever he has a fight with me, he never used to attend the class. No, no, I'm not studying like this. Okay, okay, good. So we were discussing about these elements. Kyra, we did a lot. You were not there for nearly 30 minutes. Can you watch the recorded session? Okay, now let's start from here only. So we started talking about mercury, which is liquid. Now we were talking about alloys. Kyra, you know the alloys? We discussed this in the last class also. So what is the alloy of iron? Do you
Do
remember?
you mean like
Iron. You are using it every day in your kitchen. Steel,
oh
right?
yeah,
Mm. What's the alloy of the copper? Brass
copper?
and bronze. Similarly here, Aditi, you see, now they have started talking about the alloys of mercury. But mercury is a liquid. So when we make a alloy of the mercury, is slightly in the liquid form, and we call it as amalgam. Mercury alloys are called as amalgams, right? Like for example, it's
Yeah.
a, it's a very big statement that the alloys of mercury are called as amalgams. Like for example, if I say sodium amalgam, what does it mean?
It means that sodium is mixed with mercury.
Yes. If I say lithium amalgam,
Is mixed with mercury.
yes. If I say aluminum amalgam,
Aluminum is mixed with mercury.
yeah. So amalgam word means mercury. The amalgam, right? So
Mhm.
sometimes there is overwriting because of the with grown-up children, I don't care. But for you young students, I have to take care of that amalgam. So what are amalgams? They are the alloys of mercury.
Mercury.
But they can be with any metal. The way I said sodium, lithium, gold, silver, tin, copper, right? And you have seen that when you go to a dentist and he generally does a kind of filling. What is the color of that
Oh
filling?
yeah. Isn't it
I think it's
purple, I
pink. It's like pink.
Yeah, pink, purple, or something.
Oh,
Yeah, it's like
okay.
pink.
Like earlier it used to be shiny silvery.
Oh,
And
over here it's like pink.
yeah, they give silver with
Like
mercury.
orange.
Amalgam.
Why do they put silver with mercury? Is it so
Because
that it becomes hard?
yes, it becomes first they need in slight in the liquid form. Once they fill it, it becomes harder there.
Or maybe they just changed the colors of it.
Maybe they have started using new materials. Many new materials are coming, children. Many new discoveries are done. Okay, if you see totally white, silvery color, then definitely silver with mercury. But mercury is not good for health, right? I told you that. Mercury is like a poison. So if mercury goes inside the body, it can give you many problems. So that's why maybe they have stopped using it. Mercury and silver amalgam, they must have stopped it. So it is used for years to fill tooth cavities. See here. Because they are strong, durable. You can fill it in the cavity and make it harder. Oh, see what Kyra is saying. Now dentists, they use tooth colored plastic fillings.
Yeah.
pink and all these.
Because I had a lot of fillings before
But
and they were all
why?
like pink.
Why are you having so many fillings, Kyra? Is it your with the milk teeth? Means all your teeth have come out and new teeth have come. Permanent are there?
There's some of them are permanent, not all yet. I have like a couple more left.
Okay, then please take care of your permanent teeth, right? So I'm the I'm the person. Uh, I'm lucky that I need not to visit the dentist. My husband so frequently every month. My children also. But somehow I'm lucky. You have to take care. That's it. Eat good food. Okay, it's not only brushing or all these things. I don't think it is the good quality of the enamel over there. You need a good quality calcium. Amount of calcium in your body should be good so that it can take care of everything.
I
Yes,
also have like
Kyra?
a question.
Mm-hmm.
It's not exactly like related to chemistry. So because I'm gonna go somewhere for winter break, if those classes are gonna be canceled or if they're gonna be moved around a little bit, then in India, what are the timings and the dates gonna be for each of the classes?
Okay, in India right now the time is your 9:30 starts, 9:30 a.m. in India. Yes, Aditi?
9:30 a.m. it starts.
Mm. And it finishes by 10:30. But actually, your mother requested for cancellation of them,
Yeah,
and
but if the
Aditi's
other ones don't like agree with that, then
no,
then
Aditi's
I might
father
have to.
no, Aditi father he agreed.
Oh,
So if
okay.
out of three, two have
I
agreed,
might be busy. Yeah, we're
y-
also probably gonna be busy.
yeah. So let's enjoy holidays, right? We are learning a lot.
Mhm.
Okay, so classes are cancelled. The date which I think Kyra's mother mentioned will cancel from that day to 1st of January. Yes, Aditi?
Question, you know how said earlier that mercury and bromine were liquids? If you said that mercury alloys are called amalgams, if you did mercury with bromine, it would all liquid. Would there be like no?
Oh, alloys. What are alloys, Kyra? Aditi?
Aren't
Is it
alloys
metal with
solid?
metals or metals
They're
with non?
Metals with non.
So
metals.
with metals.
Yeah.
You check the
Metals with
definition. It's a
metals, yeah.
homogeneous mixture of metals. So
Oh,
Aditi said,
mixture of two or more metals, yeah.
yeah, homogeneous, right? So Aditi said, okay,
Mhm.
let me mix this mercury with bromine. But bromine is non-metal, Aditi, right?
Yeah.
So that will not be an alloy. In fact, they are not soluble into each other. They will be lying there. You put mercury in water, they will not make a homogeneous mixture. Mercury will settle down. It's more denser. Water on the top, mercury at the bottom. You can see both of them. Okay. Okay. Now we discuss about the alloys of the mercury as amalgam, and we have discussed everything about mercury is poisonous and all these things. Then there is one very important compound of the mercury, which is called as cinnabar. This is how mercury is found in the earth crust. It's a mineral. It's the mineral of mercury. Remember we did the mineral of iron as hematite, magnetite. Mineral is, it is the form in which it is present in big amounts in the earth crust. That is a mineral, right?
Cinnabar is a mineral of mercury that is found
Cinnabar
in
is a
Earth's
mineral of
crust.
mercury. And it is actually HGS.
That means I thought
Mercury sulfide.
Question.
Yes.
Is it found in crust too?
Say again. It is found in earth crust.
Yeah.
In Earth's
Earth's crust.
Earth's crust. What is earth crust? I think you know. It's made up of soil, right? Rocky material, soil, all these things.
Mhm.
So these metals are found as compounds in the earth crust, and that that
Oh,
soil is called as mineral.
oh,
Salts
okay.
present in the earth's crust. So we are good with mercury. When you are coming to
Yeah.
India, Kyra? When?
I'm gonna come. I'm gonna leave here the 17th. I think I'm gonna arrive there like the 19th. Yeah.
And Aditi, what about you?
Oh,
You're not going to India?
I don't think, but I want to go with my mom in the spring again.
Okay. Okay. That's good. So those who are coming to India, they are most welcome to join me in Shimla, right? Okay, now halogens. Check which family is called as halogens.
The oxygen family.
The
No.
group
Oh no,
17.
the fluorine.
The
Wait,
fluorine.
group
Yeah.
17,
Group
fluorine.
17
Yeah.
fluorine.
And this family is totally non-metallic, right?
Yeah,
Non-metals.
non-metallic.
They gain electrons, they don't lose electrons, and they all are diatomic in the elemental state. So we are
Yeah.
talking about which family now? Halogen family, this one. Are they reactive
Wait.
non-metals or less reactive non-metals?
They
These are
are
They are
very reactive non-metals.
reactive. Yeah.
Very
Because
reactive. The most
they-
reactive. Because
Yeah.
they, completed.
Because they gain electrons and they're like the smallest.
Number of electrons needed. They can
Yeah,
gain
and
easily.
then they can easily gain electrons,
Yeah, because they are very small and they have to gain only one.
and like whenever they like, especially like the top row, whenever they get bonded with like another non-metal, it's
Mhm.
going to be very reactive because it's going to pull the bond more closer to itself.
Yeah, that electronegativity you are talking about. Very good.
Mhm.
Okay, Aditi, what's your question?
You said something about diatomic. Could you
Yeah,
repeat
these
that?
all are diatomic.
Oh
They
yeah,
exist
they
in the
are.
diatomic form. These are non-metals, very reactive. They are diatomic. If you leave this last one, these two, leave these two. Can you give me the formula of these one? In the pure elemental form? Diatomic. So what is the formula of F, Aditi? You just did it before Kyra.
H, H,
F2. F2 is a
oh, and
gas.
then yeah, it's
Then
just a Cl2,
two.
which
Two
is
means,
also a
what is the meaning of
gas.
two? Two means diatomic. Di means two.
Di means two.
Mhm.
It's still a diatomic gas.
Yeah, it is still a gas. Then
Bromine is
Br2.
R2 and is a diatomic but liquid. It's
Yeah,
liquid.
yeah. And what about I?
Diatomic I2. And it is solid.
Yeah, it is solid. See, gas, liquid, solid. Very important. So, can I make one more question based on it? Give me 1 second. I'm not well, so I'm sneezing a lot. Okay. Making one more question. Can you see F2 is gas? F2 is gas.
Gas. Yeah.
Cl2 gas.
Gas.
Br2 gas.
Liquid.
Oh,
Yeah.
liquid. Yeah, liquid. Sorry. And I2 solid.
Solid.
Let's make the molecular picture. If it is a gas, molecules are far away.
Mm-hmm.
This one also, molecules away.
Well, wait.
But in
For
molecules
liquid,
liquid, they're more close together,
more close
but they're
together.
not exactly touching each other.
Liquid.
And for
Solid
solid,
is
they're
exactly
really close
touching.
together.
so what
They're
is
like
happening to the
touching.
attraction?
It's
The
increasing.
attraction is increasing.
Increasing. Yeah, attraction is increasing.
As we
So
move
as the
down
attraction
the molecule.
increases, state changes, right? As the attraction increases, state changes
Changes.
from liquid, gas to liquid to solid.
Solid.
So these are non-matters. They are very reactive. They exist in the diatomic form, right? And they can gain 1 electron. They are very electronegative because they are very small in their particular period. They are the smallest. Yes, Kyra.
I thought that like down the group, when you go, it's gonna be like less attraction because it gets a bigger size.
Oh, okay. That's a different concept altogether.
But then
You're
when you
talking
said
about
that they're
that
more
Coulomb's law.
attracted, no, but when you said that they're more attracted,
Mhm.
then isn't more attraction more on the top and not on the bottom?
Oh, okay. You see, she's talking in terms of that Coulomb's law, F equals to K, Q1 over
Q1.
Q2 over
Q2
R squared.
over R.
She's thinking this R. Okay, but here the problem is, if you look at this H2, your F2, which has very small R, very, very small. But this formula I'm using on this bond. They are sharing electrons, right? R is small, so force of attraction in this bond is very large. But if I talk about this bond, iodine is bigger. The force of attraction of this iodine atom, this bond, is weak.
This week.
Weak.
This is strong,
Strong.
right? So here more energy is needed. Here R is less, here R is more. Here this formula is well fitted. But right now I'm not talking about that. I'm talking about F2 molecule, F2 molecule. This is F2 molecule. Another F2 molecule, another. So here another kind of chemistry starts playing a role. If the atom has, molecules have big size, if the molecules have big atomic number, then they are more attractive because there is another concept which we have not done and will not do it. We'll do it later on. Okay. But it's very nice, Kyra, you asked the question. So use this equation to compare the bonds, right? To compare the charges. But when we are comparing the complete molecule, then there are many other concepts which are important and we'll discuss about it. Yes, Aditi.
Halogens react with metals to form salts. Is that why its name is, it says the name halogen comes from Greek words halos meaning salt and then genin meaning to form or generate. Does that mean halogens?
Are present in the form of salts.
Yeah.
Yes. Can you tell me why is this so? This one. They are not, they're actually pure. Means you can never see, you can never see
them on Earth.
in the elemental form, right? Cl2, F2, I2, and Br2, they are never found in nature. Because they are the most, they are never found in nature, right? Because they are
reactive
very
metals.
reactive. Yeah. So how are they found? They are found in the form of how you are going to find these elements in the nature as salts, like NaCl, NaBr. These are present in seawater, NaI, KBr, KCl, KI, MgCl2. So they are present in seawater. They are also present in rocks. So generally they are referred as, so what are these compounds referred as? This is chloride,
Salts,
bromide,
chloride, bromide.
halides. So they are called as halides. See this line. Halogen reacts with metals to form salts. These salts are called as halides. Sodium chloride, calcium chloride, right? So they are called as halides. So we are good with this? Halogens? Family, the most reactive, what is important to take away from here? Most reactive non-metals, never found in free state, always combined with metals to give salts. Salts are called as halides. They all can gain one electron easily because they are smallest in their respective periods. So they have very high tendency of gaining electron. Okay. Okay. So fluorine is most reactive non-metal in the family, yes or no? Yes, Aditi?
Yes, I think
Yes. What happens to non-metallic character as you move down?
decreases.
Yes.
Decreases.
Because the size is increasing, the tendency to
Increasing.
gain electron decreases. So
Mhm.
fluorine is the most non-metallic, most reactive non-metal.
And most electronegative
Yes,
element.
yes, because it is the smallest and it is the most reactive metal also. The color is pale yellow, green color. You can never see in fluorine gas in the nature. It has to be made in the lab, right? Highly corrosive. What is the meaning of corrosion?
Like, s- what's it called?
It will oxidize metals.
Yeah,
It will oxidize. Not itself. Like for example, you put sodium metal and you add fluorine gas. Immediately they will react to form sodium fluoride. Very fast explosive reaction. So here sodium is losing one electron, fluorine is gaining. What is loss of electrons? Remember loss of electrons? Yes, Aditi?
Question. The halogens aren't the most reactive though, right?
Halogens are the most reactive non-metals, yes.
Oh, non-metals are.
Not metals.
I thought you were talking about in general.
They gain electrons. They are very small. They gain electrons to complete the octet, just like noble gases. So they are non-metals, right? Okay, loss of electron is, Kyra? Oxidation, you're forgetting about it. And gain of electrons is
Um, reduction.
reduction, yeah. So sodium is losing electron and fluorine is gaining electron. This is called as corrosion. When metals, they get oxidized in the presence of oxygen, fluorine. These are very reactive non-metals. They all have tendency to corrode. Corrode means to oxidize metals.
Two.
You know, you take glass material, glass material. You put that glass material in HF. This is hydrogen fluoride. You know, it will dissolve. So it's a very important material in the market. You know, how people they give different shapes, they put scratches on the glass, they make designs on the glass. So at that
Yeah.
time they are using this HF. HF is also very reactive because fluorine is there. HF is also very corrosive because of the fluorine, because of the presence of fluorine. So the important compound of F is HF, which is used in glass industries and is also very soluble in water. So I think we have to end the class here. Yes, Kyra, your question?
When I was looking through my notes, I wasn't able to find like the proper definition of oxidation. So can you give me like the
Mhm.
actual proper definition of it?
Yeah, you remember I was writing there. So that's the definition. So what is oxidation?
Loss of electrons?
Yeah, that's the proper definition. Big definition. There are so many simple definitions. But oxidation reduction you have not done clearly with me because it's not the part of this YBTC I've seen. But I'll teach you separately. And reduction,
Gain of electrons?
Gain of electrons.
I'll give you plenty of such definitions, more definitions of oxidation and reduction. But right now, let's stick to this major definition. Electrons. Loss of
Wait, so that's called reduction.
reduction, gain of electrons. So metals, they get oxidized or reduced. Metals, they lose electrons, remember?
Those electrons, yeah.
So they oxidize. And non-metals,
They gain electrons,
so
so
they
they
are
reduce.
reduced.
That's reduced.
So I can end the class now. So next week, the vacation is starting. So no class next week.
Oh, there's no class.
Okay, so
No,
please
I think
confirm
it's
this.
next to next.
No, this
Like
is
next
For a
like
month
next
or
week,
two.
there's still gonna be like school and all next to next week.
okay. I'll check the
Ah.
days. Okay, confirm the days from when
Next
you
week
want
is
to.
for school.
Yeah, just confirm the days from which you want to stop the classes. Okay.
Okay.
See you then. Bye bye.
Bye.